System of particles under rotational motion. System of particles under rotational motion. சார் இப்போ ஃபர்ஸ்ட் பார்த்தீங்கன்னாப்பா நம்ம பார்த்தீங்கன்னா சென்டர் ஆஃப் மாஸ் பற்றி பார்ப்போம். Center of mass. So what is center of mass? The point where whole mass of the system is supposed to be concentrated, that is called center of mass. The point where whole mass of the system is supposed to be concentrated. Supposed to be concentrated. Next, properties of center of mass. இதில் ஃபர்ஸ்ட் பார்த்தீங்கன்னாப்பா the location of center of mass is location of center of mass weighted average of the location of the particle of the system. The location of particle of the system. Second, center of mass moves. Center of mass moves as external force act on the entire mass. External force act on entire mass concentrated at that point. Concentrated at that point. In absence of any external force, the center of mass moves with a constant velocity. So next, position of center of mass of system. Position of center of mass of system. Position of center of mass system which is equal to summation of I which is equal to 1 to n mi ri divided by summation of mr. Next, velocity of center of mass of system. Velocity of center of mass of system. Velocity of center of mass which is equal to summation of I equal to 1 to n mi vi divided by summation of mass of ith particle. Next, acceleration of center of mass of system. Acceleration of center of mass which is equal to summation of I equal to 1 to n mass of ith particle and acceleration of ith particle divided by summation of mass of ith particle. So next, rigid body. A body with a perfectly definite and unchanged shape. A body with a perfectly definite and unchanged shape. And unchanged shape. ஸோ ரிஜிட் பாடியில் வந்து பார்த்தீங்கன்னாப்பா நமக்கு ரெண்டு டைப் இருக்குது. ஒன்று வந்து பாருங்கள், ரொட்டேஷனல் ஈக்லிபிரியம். ரொட்டேஷனல் ஈக்லிபிரியம். நெக்ஸ்ட் டிரான்ஸ்லேஷனல் ஈக்லிபிரியம். டிரான்ஸ்லேஷனல் ஈக்லிபிரியம். இப்போ ரொட்டேஷனல் ஈக்லிபிரியம் பார்த்தீங்கன்னாப்பா எக்ஸ்டர்னல் டார்க் which is equal to 0. So translational equilibrium, external force which is equal to 0. Next, equation of rotational motion. So first one, omega 2 which is equal to omega 1 plus alpha t. Second பார்த்தீங்கன்னா theta which is equal to omega naught t plus 1 by 2 alpha t square. Third, omega 2 square which is equal to omega 1 square plus 2 alpha theta. So now analog between linear and rotational motion. Analog between linear and rotational motion. Linear and rotational motion. First, linear motion. Rotational motion. So linear motion velocity, we can specify v equal to rate of change of displacement. So angular velocity omega which is equal to d theta divided by dt. So next, linear motion acceleration, a which is equal to dv by dt, rate of change of velocity. Angular acceleration alpha equal to d omega divided by dt. So next, force F equal to ma equal to d by dt of mv, rate of change of momentum. So torque tau which is equal to I alpha. Next, work done, linear motion work done, force into displacement. So rotational motion work done, W is equal to tau into theta. Linear kinetic energy, linear kinetic energy which is equal to 1 by 2 mv square. Next, rotational kinetic energy, rotational kinetic energy which is equal to 1 by 2 I omega square. So power P equal to force into velocity, power P which is equal to tau omega. Linear momentum, linear momentum P which is equal to mass into velocity, angular momentum. L which is equal to I omega. Next, torque. The torque are couple of moment of force tau which is equal to R into F. So tau which is equal to RF sin theta. The torque rotational torque which is equal to I alpha. Next, angular momentum L which is equal to I omega. So angular momentum which is equal to mass velocity into radius mvr. So angular momentum L equal to R into P, Rp sin theta. Next, kinetic energy. Rotational kinetic energy. Rotational kinetic energy which is equal to 1 by 2 I omega square. Kinetic energy rolling which is equal to 1 by 2 mv square plus 1 by 2 I omega square. So next, velocity, acceleration, the time of descent for a body, rolling, and inclined plane. Inclined plane. Body. Next, velocity. Next, acceleration. Time descent. So the general formula velocity வந்து பார்த்தீங்கன்னா v equal to root of 2gh divided by 1 minus k square 1 plus k square by r square. So acceleration a which is equal to g sin theta divided by 1 plus k square by r square. Time descent t which is equal to 1 by sin theta root of 2h divided by g 1 plus k square by r square. So now body வந்து பார்த்தீங்கன்னா ring or hollow cylinder. Ring or hollow cylinder. The ring or hollow cylinder velocity root of 2gh, acceleration 1 by 2 g sin theta, time descent 1 by sin theta root of 4h divided by g. Next, disc or solid cylinder. Disc or solid cylinder. velocity root of 4gh divided by 3, acceleration 2 by 3 g sin theta, time descent 1 by sin theta, whole divided by 3h divided by g. Next, solid sphere. Solid sphere root of 10 by 7 gh, acceleration 5 by 7 g sin theta, time descent 1 by sin theta, whole root of 4 by 7 h by g. So next, hollow sphere. Root of 6 by 5 gh, 3 by 5 g sin theta, 1 by sin theta, root of 10 by 3 h by g. Next, moment of inertia. Moment of inertia. Moment of inertia I which is equal to mass and distance square. Summation of I equal to 1 to n mass of ith body and Ri square. Next, radius of gyration. Radius of gyration k which is equal to under root of r1 square plus r2 square plus r2 plus rn square divided by n. Next, k which is equal to root of I by m. Next, theorem of moment of inertia. Theorem of moment of inertia. So first, theorem of perpendicular axis theorem. Perpendicular axis theorem. So Iz which is equal to Ix plus Iy. So Ix, Iy and Iz moment of inertia about perpendicular axis. Ix, Iy and Iz moment of inertia about perpendicular axis. About perpendicular axis x, y, z. So next, parallel axis theorem. Parallel axis I which is equal to moment of inertia about parallel axis the center of mass plus mx square. ICM which is equal to moment of inertia about the center of mass. So next, moment of inertia of some regular shaped body. First, rod moment of inertia of center of mass which is equal to ml square divided by 12. Moment of inertia 1 inch which is equal to ml square divided by 3. Second ring moment of inertia of center of mass which is equal to mr square. Moment of inertia of diameter which is equal to m r square divided by 2. Next, disk moment of inertia, which is equal to m r square divided by 2. Moment of inertia of diameter, which is equal to m l square divided by 4. For a solid sphere, moment of inertia of diameter, which is equal to 2 by 5 m r square.